Good evening, Bearcats. We're going to do A.4 tonight, rational expressions. As I said earlier, I'm going to look for these tomorrow in your notes. I'm going to make sure that you've written these examples down. This will also give you an example for each of the types of problems you'll do for classwork tomorrow. All right, so we're going to go ahead and start. You can call this A.4 rational expressions, and these are examples from your classwork. We're going to start with number 8. Actually, we're on page, and just in your book, your assignment, your classwork assignment tomorrow is going to be page A43, problems 1 through 27, 35 through 41, 43 through 51, 61 through 65, and 73 through 75 odd. Okay, so it's all odd numbers, and we're going to start with problem number 8. Problem number 8 is about the domain. We're asked to write the domain. We got some of you got to this in class today, but we were kind of rushed. I want to talk about it again. We were given the function, the square root of 6 minus x. And I want us to remember that underneath the radical, it can be greater than or equal to 0. Okay? So in other words, we can have the square root of 0 or the square root of a positive number, just not the square root of a negative number. So because we know that, I want us so it can be greater or equal to 0. Because we know that, we're going to take this information and we're going to write it as 6 minus x has to be greater than or equal to 0. And then we're going to just solve it. We're going to subtract 6 from both sides. And you have negative x is greater than or equal to negative 6. And then here's a big thing. We're going to divide by a negative on both sides. When we do, you're going to get a positive x. But remember, we just divided by a negative. And when we divide by a negative, remember, you should hear the little bell in your head. The inequality sign needs to switch places. And now we divided by a negative on this side, and so we have a positive 6. So our value, x, is less than or equal to 6. You can always test it out, and I would, just to make sure you catch all your mistakes. So less than or equal to 6. If I put a 6 there, I get a 0. That's a good 6 minus 6 is 0. Square root of 0 is good. Less than 6. Let's pick 0. So 6 minus 0 would be 6. The square root of 6 would be a positive number, and that is good. All right, let's move on. Next problem we're going to do is problem number 11 from that classwork, and this is to simplify. So we're simplifying. This is a little bit about a review about exponents. We have 15x squared over 10x. You just want to be really careful. You're going to think in your head 15 over 10, and then you're going to think of x squared over x. We'll put them back together. 15 over 10 can both the top and the bottom can be divisible by 5, and you would reduce that to 3 over 2. And when you have an x squared, excuse me, x squared at the top and an x at the bottom, remember if you have the same base, you subtract exponents. That would put us an x, 2 minus 1 at the top, or just an x at the top. You can also think of this as an x and an x and an x in the bottom, and you cancel 1. So you end up with just an x at the top. So 3 will have an x by it. And you will end up with 3x over 2 as your answer. But be careful, you also have to add the restriction. Remember, before we made any cancellations, if you had x had been 0, it would have caused a 0 in the denominator. So our restriction is x cannot equal 0. X cannot equal 0. All right, let's go on to the next problem. We're still simplifying, and this is going to be problem number 21. Problem number 21. I'm going to go ahead and just get a clean page. It'll make it easier for us to see. Problem number 21, but we are continuing to simplify. The problem we're given is x cubed plus 5x squared plus 6x. And we're going to divide that by x squared minus 4. So we're just simplifying this. Notice we're not solving anything because it's not equal to anything. You really need to pay attention to that. Sometimes you start wanting to solve things when you see a bunch of x's, but you've got to be careful. We're only asked to simplify it. The first thing we're going to do when we want to simplify, we're going to factor all we can. and we're going to make cancellations. All right, so we're going to oops, I made my little face off there. Factor all we can and make cancellations. So let's look at the numerator. In the numerator, we have a common factor of x, and inside then we would have x squared plus 5x plus 6. And in the denominator, this is a difference of squares. So you should know pretty immediately it's going to be x plus 2 and x minus 2. All right, I believe at the top we can go ahead and factor a little bit more. This can also be factored out. So we have x, and now we're going to factor this, and that is a factor. And we're going to factor this down to 2, break this into 2 more. So we have x, and we want to multiply to 6 but add to 5. I believe that's positive 3 and positive 2. All over x plus 2, x minus 2. All right, before we make any cancellations, I want us to write our restrictions. So we know that x cannot equal negative 2 or positive 2. So now we're going to make our cancellation, and our equation simplified is x times x plus 3 over x minus 2 with that restriction, and that would be our answer. All right, now we're going to go on to problem 39. 39, we're asked to multiply or divide. We're using multiplication or division, and then we're going to simplify. That need another I in there. All right, multiplication or division to simplify. All right, so let's get our problem. Our problem is t squared minus t minus 6 over t squared plus 6t plus 9, and we're going to multiply that with t plus 3 over t squared minus 4. All right, again, one of the things we want to do to simplify is we're going to factor what we can, cancel what we can, then we're going to put things back together. So we're going to, and we're not going to multiply them back together, we're just going to simplify it then. So we're going to factor, we're going to cancel, and then we're going to simplify. Okay? And we're going to write our restrictions. All right. All right, so let's do that. Let's factor first. I believe this numerator right here could be factored into t and t. We need to multiply to negative 6 but add to negative 1. So I believe that's going to be a negative 3 and a positive 2. In the denominator, I believe we can break that into 2 linear factors. That's going to be t and t. Multiply to 9, but add to positive 6. I believe that's plus 3 and another plus 3. On here, we already have just a plus t plus 3. And in the bottom, this is a difference of squares. We can break that into 2 linear factors, t plus 2 and t minus 2. All right, we factored everything. Once again, before we make any cancellations, we need to go ahead and write our restrictions. So I'm going to come over here to the side and write x cannot equal. It cannot equal negative 3. That's also negative 3. You don't need to write it twice. Can't equal negative 2. And it can't equal 2. And now we're going to make our cancellations and simplify. So I have one x plus, or t plus 3, and I have another t plus 3. I have a, and I guess this should really over here, sorry, this should say t cannot equal. T cannot equal. I have a t minus 3. I don't have any t minus 3s. I have a t plus 2, and I have another t plus 2. And I believe that's all my cancellations. So I would end up with t minus 3 over t plus 3 times t minus 2, with these restrictions that t cannot be negative 3, negative 2, or 2. So here we go. All right, moving on. Next, we're going to go to problem number 43. Problem number 43. And now we're, and now we're adding and subtracting. and then simplifying. Again, none of these, we're not solving any of these because they're not equal to anything yet. So we've got to be really careful. If we're just simplifying, then there will be x's and variables left in our answer. Later on, when we start solving, then the x's will be actually solving and getting a value for x. But right now we can't do that since they're really not equal to anything. All right, so let's write our problem down. Here we have 5 over x minus 1. And we're going to add to that x over x minus 1. Oh, well, this one's pretty happy. We're pretty happy in this case. Actually, let's make him a jack-o'-lantern. Okay, since it's Halloween. Here. I didn't do a very good job of that. There's little teeth. You see little teeth? All right, so there's your jack-o'-lantern. Oh, we'll put a little jack-o'-lantern thing on him. All right, anyway, so we're pretty happy right now because these are already the same denominator. Remember, when we're adding and subtracting, we have to have common denominators. So when we do that, we're going to write our denominator once we find a common one. So it'd be x minus 1. And all we would do would be combine the numerator. And in this case, since there's nothing to multiply or anything, we just have 5 plus x. Or we could do x plus 5 to make it look a little bit more the same. So we could say x plus 5. And then that was just pretty simple and done. Now we're going to get to 49, and 49 is where we end up having to find a common denominator. So for problem 49, we start with 1 over x squared minus x minus 2. And then we're going to subtract. That makes it doubly hard there with the subtraction, or more complicated. And we have x over x squared minus 5x plus 6. All right, well, the first thing we're going to do is factor again, because we need to see to find a common denominator, we need to know what factors are within our denominator. So the first thing we're going to do is factor. Notice I'm writing directions over here to the side. All right, we're going to come down and do that. I'm going to just right underneath here take a look. This would be linear factor x, and multiply to negative 2, add to negative 1 would be a negative 2 and a positive 1. So this kind of just replaces this. Sometimes I just kind of cross it out. And then I'm going to replace over here x and x. Multiply to positive 6, add to negative 5. I think we could do negative 3 and negative 2. And that would get us the answer. And again, we can kind of cross this out. Excuse me. All right. So when we're looking here, we have an x minus 2 and an x minus 2. That's going to be common already. So that's part of our denominator. We have an x plus 1, but not over here, so we have to include that in our denominator. So that takes care of the left side. And over here we have an x minus 3, so we'd have to make that part of our denominator. All right, so all three of those become the common denominator. On the left side over here, this has x minus 2 and x plus 1. You would need to multiply by x minus 3. And if you do that in the denominator, you also have to go up here and do that in the numerator. Let's go ahead and do that. So 1 times x is x, and 1 times negative 3 is negative 3. Be really careful with subtraction. Please attach that subtraction sign as like a negative to this. This is like a negative x. That will help you. On this side we have x minus 3 and x minus 2, but we do not have x plus 1, so we'll need to add that one. And so we would multiply by x plus 1 at the bottom and the top. All right, so let's distribute. Negative x times x is negative x squared. And negative x times 1 is a negative x. All right, we've done all the hard part. Now we just need to simplify. So we factored. We found the common denominator. We then are going to simplify to our equation. So let's take a look at now what we're going to do. All right, so first of all, we want to simplify the numerator. We have an x and a negative x, so I guess those are going to cancel out. We have a negative x squared and a minus 3 all over our denominator. X minus 2, x plus 1, x minus 3. And now let's just take, we could leave it like this. I would be fine with this. A lot of times they don't like this negative hanging out front here of the numerator. They like it out in front of the whole fraction. So let's do that. Let's pull this negative out in front of the whole fraction. So then your fraction bar would be right here. If we do that, our denominator is going to stay the same. But be very careful. We're going to put a parenthesis here. And to get back to negative x squared, I'd need just x squared. And negative times positive 3 would give me negative 3x or minus 3x. Be really careful, that changed the sign. So either one of these are equivalent. All right, let's move on. We have 2 more problems, I believe, to work. Actually, 3 more problems. We're going to work problem 61. Hope you're giving out lots of candy to the little kids tonight. All right, problem 61. Again, we're going to simplify our problems. And this time we have negative exponents we're dealing with. And this is a little tricky. This is something that you have not done before. This is brand new. So this is new. You've never seen it. So pay really close attention. We're going to do 2 of these. The first one's fairly simple. The second one is a little more complicated. So we have x to the 5th minus 2x to the negative 2. Okay, what you're going to do is you're going to factor out the variable with the lesser or least, not sure which is proper English, exponent. In other words, with the smallest exponent. Often that means the negative exponent. All right, and then we're going to simplify that. So if I look at x to the 5th and x to the negative 2, obviously x to the negative 2 would be the smaller exponent. So they both have an x, but negative 2 is smaller than 5. So I'm going to factor out x to the negative 2, and then I'm going to put a parenthesis. And then I have to just think a little bit. We know when we multiply bases of our variables, we add exponents. So you have to really think about that. So x to the negative 2 times something gives me x to the 5th. So x, I need to put something right here. When it's added to negative 2 would give me 5, and I believe that would be 7. So negative 2 and 7 would give me the 5. And then we're going to subtract, because this is subtraction. We're going to need a 2, and that's all we need because we have x to the negative 2, and that would be x to the negative 2, and yet 2 would get that. The last step, though, is we want no negative exponents. So we're going to take this x to the negative 2 and we're going to move it downstairs, and it will change our exponent to positive. So our final answer here would be x to the 7th minus 2 over x to the positive 2. That would be our final answer. All right, let's look at 65. It's a similar problem, just a little more complicated. And 65, we have 2x squared, and then parentheses x minus 1 to the 1/2 power. And then we're going to say minus 5, and then it's x minus 1 to the negative 1/2 power. All right, I want us to factor out this x minus 1, and the one you've got the exponents is what you're trying to factor out, with the negative exponent. That's a negative 1/2. So I'm going to factor out x minus 1 to the negative 1/2 power. I'm going to put this bracket here. So now I'm looking at this term right here. I already have x minus 1 to the negative 1/2 times, I need to multiply it to get to this. I would need the 2x squared. I don't have that. I have the x minus 1, but I have a negative 1/2. So I'm going to have an x minus 1, and this variable has to be, or this exponent has to be added to negative 1/2 to equal positive 1/2. What plus negative 1/2 equals positive 1/2? I believe that's just a 1, so we don't even have to write it, but I'm going to go and put it there so you know. 1 and negative 1/2 give me positive 1/2. All right, and then I'm going to subtract because this is subtraction, and obviously I need 5. And I already have x minus 1 to the negative 1/2, so I'm done with that. I'm going to close that bracket. Now I'm going to simplify. So the first thing I'm going to do is I'm going to take this, and this will get moved below, so it's a positive exponent. So this is going to be x minus 1 to the positive 1/2. You could write that, by the way, as the square root of x minus 1. The 1/2 power is the same as the square root. Either one, I'll take it either way. All right, up at the top, though, we're going to distribute. Since this is a 1, we don't really need to do anything with x minus 1, but we can distribute. X squared minus, or x squared times x, 2x squared times x would be 2x cubed. And 2x squared times negative 1 is a negative 2x squared. And then we would have minus 5. Minus 5. And we could just leave it like that. So you could leave it like this, or you could write it as 2x cubed minus 2x squared minus 5 with the square root in the bottom. Either one. I'll take it either way. All right, and that's just simplifying. Remember, these are not equal to any value. We're not solving for x because they were not equal in the beginning. All right, last problem for tonight, and then that will be Happy Halloween to you. So let me just draw you one of my renditions of one of my little pumpkins. I like to put little eyes in my pumpkins. I don't know why. It makes them look happier. Okay, Happy Halloween. And go Bearcats. All right, last problem, sorry. 73. Problem 73. We're going to actually, we've rationalized denominators this year. We're going to do something weird. We're going to rationalize a numerator, which is kind of strange. So we're going to take this problem, which is the square root of x plus 2 minus the square root of x all over 2. And we're going to simplify it by rationalizing the numerator. And I'm not sure in the end it looks much simpler, but it is a way to manipulate an equation. And that's really what we're trying to get at, is that you can manipulate these equations to fit your needs. As you move further along in math, that's going to be very important that you're able to manipulate the equations. And so you want all the ways you can manipulate. If we take this numerator and we want to rationalize the numerator, then we're going to multiply by its conjugate. And we've talked about conjugates a lot this year. So the conjugate would be the square root of x plus 2, but instead of minus, it would be plus the square root of x all over, oops, sorry about that. Now that I need to fix. Ah. Not want me to fix that. Okay, sorry, I don't need the 2. All right, so we would rationalize the numerator by multiplying by the conjugate at the top and the bottom. All right, so let's take the numerator first. Because they're conjugates, just like always, the middle terms would always cancel, so you only need to multiply the first times the first. If I multiply the square root of anything times the square root of itself, then it just makes my radical go away. So the square root of x plus 2 times the square root of x plus 2 is just going to be x plus 2. Then if I take a negative times a positive, I'm going to get a negative. If I take the square root of x times the square root of x, it's just going to be x. In the bottom, I have 2 times all of this stuff. I'm just going to write it just like that for right now. Just 2 times, and then I'm going to say the square root of x plus 2 plus the square root of x. All right, in the numerator, be really careful. We've got some simplifying to do. We have an x and a negative x, so those are going to cancel. So you have a 2 at the top over a 2 at the bottom. That's going to cancel in just a second. Go ahead and write it one more time. X plus 2 plus the square root of x. Now all of a sudden our 2's cancel, and it leaves us with 1 at the top. And our final answer is 1 over the square root of x plus 2 plus the square root of x. And that is your final answer. All right, go Bearcats. Have a good evening, and I will see you tomorrow. Night.